Boys and girls, this is another opportunity for you at home to build a bottle biome. I've got all my materials ready. I found myself a nice 2-liter bottle, and I have a little trick that I showed the folks in class, and this is something you can keep in mind just to prevent yourself from getting injured. When I start the bottle biome, cutting the top of it off.
Ooh, good idea. Use a pin to...
I use a pin. Let me just put this down, this pre-cut one. I'm kind of giving away my tip here. But yeah, what I do, because these things can be really kind of difficult. I don't want anybody jamming a pencil or
knife.
Something sharp or a knife. No, that's not the way to go. Find something sharp. This is just a thumbtack. You poke a hole in there like this.
Ooh, to get it started, I see.
To get it started. And then you take a pencil, it doesn't have to be even a sharp pencil, and you put it in that hole.
Once the hole's going.
Once the hole's in there, and you force it like that. And what that does is it gives you a pretty good size hole in which you can put your scissors.
Oh, I see.
And then you simply put your scissors into the opening and just start a little slit like that, and sure enough, before you know
and your parents can totally help you with this part.
Absolutely, absolutely. Now, once you've got it open, I know you guys probably all know to rinse the bottle out, but if you haven't done so, this is a good time to really get in there and clean it out.
But no soap.
No soap, absolutely not. Mr. M's right.
Why?
So, because soap, it's toxic to organisms, and you know, this is a biome, so we're fully aware that biomes contain organisms, biotic factors, and we want to keep those healthy and free of any detergent or soap or anything that might be harmful to them. So I just take a wet paper towel, not too wet, just damp, clean out the inside of my 2-liter bottle. And by the way, if you're using a jar, you can just screw off the top and do exactly what we're doing here. It's even easier, but these are nice. These are all around your house. You can find these probably
At the they're literally at the dollar store.
At the dollar store. You could go to your recycling bin in your neighborhood. I'm sure you'd be able to find it. Okay, now that we've got that ready, we've got a plan that we follow. And I put this, actually, Mr. M knows, I put this on the internet on our Google Slides where I show you guys how to build a biome. But this is a little plan, and you know, when we talk about, you know, engineering and design and all that, you should always have a plan when you're executing a science experiment as well. So here's a nice little model. So we're going to start off with some very precise numbers. The first one we want to check out is 2.5 centimeters. We need 2.5 centimeters of gravel, and this can, boys and girls, be just about anything. You know, this is pea gravel. It's just, you know, it's about maybe 1/4 of an inch wide, these little pieces. It doesn't have to be
rocks.
Any rocks you have, even bigger than this would be just fine. And what I want to do is I'm going to pour these in here to a depth of about 2.5 centimeters. And if you're using a ruler at home, remember 2.5 centimeters is the smaller list of numbers over here. A centimeter is about the width of your pinky finger.
So maybe there one more scoop?
Yeah, maybe one more scoop. Get that in there. And this is because you want to have good drainage in your biome. You want the water to be able to find its way to the bottom. I think that's going to be perfect.
And you can see in these, look, they're all about 2.5 inches.
Yeah.
Even with the dirt on that one.
Yeah.
Okay.
So now we got a nice layer of gravel, and in science we call that substrate.
Substrate.
Substrate. So the substrate, the underneath layer, if you will. Remember stratification in our water lesson and the Skittles lesson? Stratification means layers. It meant the same thing last year when we were studying geology. So we got our substrate. The next ingredient you can see on our design.
Soil?
Is, no, we have another
the activated charcoal, my favorite.
Charcoal. And as it happens, we have some activated charcoal that Mr. M brought for us.
Oh, look at that. I wouldn't worry about rinsing it.
This is pretty good. No, this is not going to interact with anything above it. So we've got some activated charcoal. And what we're going to do here, charcoal has long been used as a material that removes toxins from water.
Like a filter?
Yeah, it absorbs harmful bacteria, impurities in the soil, and so
Now, if they don't have activated carbon,
it'll work. It'll work.
you
fine.
still can do it, or they can even email us, and we might be able to get them some.
That's true. We have quite an abundance of activated carbon thanks to Mr. Mandeville. So we just put a layer of about 1.5 centimeters on here. It doesn't have to be terribly precise.
Looks cool.
But what this will do is it'll allow the water to be sort of filtered as it's working through the water cycle. Because as you can see from these experiments that we've already started, we've got quite a few of these that are producing water vapor.
You can see how clean my water stayed just from that happening.
Yes, very good. And it keeps your water very clean. And you can see this water will be cycling through, rising up in the form of vapor. Condensation occurs on the side of the bottle, then it's going to be falling back in. You want that water to reach its way back to the substrate, but be sort of cleansed along the way.
Okay.
So we've got that started, and
Looks
now
like
what
we're
does our
ready for
next
some
direction
soil.
say? I think
Some
we're gonna,
soil or dirt?
Yeah, soil or dirt. And boys and girls, you don't have to go out and buy some new soil or anything like that. Potting soil is great. I've done these where I've just gone literally to my backyard and gotten a couple shovels of dirt and loaded up a bucket and used that. It doesn't really matter. I got some, just sort of a combination of garden soil or potting soil.
Well, and this kind of soil is more for the tropical one, right?
Yes.
Because otherwise they could just use sand if they're going to do
Absolutely.
the
I probably
desert
should
one.
have brought that up. This is a tropical rainforest biome that we're creating, a little ecosystem. And this root system of this plant we're using, I'll show you this plant really quickly. This is called an asparagus fern. This is a type of moist soiled plant. It requires a moist environment.
More tropical, okay.
Yeah, more tropical. This grows in an environment where you've got a mean temperature, average temperature of about 75 degrees. It really doesn't fluctuate very much. Likes humidity. So since we are definitely going to have water in here cycling through, we know that we want to have a plant that really enjoys some humidity. And what I do is I keep the root ball intact. And by the way, I've had kids find little plants around their house. That's okay. Just ask mom and dad, make sure you have their permission. Once you put this in here, you won't need to water it anymore because we're going to close this ecosystem off and just maintain the water. The water will maintain
So you're
itself.
kind of putting enough around the root ball just so that it's kind of stands on its own.
Exactly. And when you put the soil around the root ball, the soil that's attached to the root, you just want to sort of gently push it down around it. You don't want to go too hard. You don't want to damage the roots. And now we're almost ready to add the water. And you can see how this is going to be a bit of a trick getting it inside when you reattach the top of your 2-liter bottle. But you certainly have plenty of room for growth. There's a little terminology, you guys. The top of a root ball is called the crown of the plant. It's just where the stems and the branches start to emerge from the soil. You want to kind of keep that level with the soil around it. And now we're ready to add water. And we're going to add 1 cup of water. And I would make sure, it doesn't have to, you don't have to go to great trouble, but if you could just find some drinking water. It doesn't have to be distilled or anything. And we're just going to put a cup of this in there.
8 ounces?
8 ounces it is. And when you pour it in here, you just want to be real careful. I always use the plant itself to sort of brace it.
Right on top of it, okay.
Yeah. Brace it.
You're not just dumping it all in there.
No, because it could displace too much soil and expose the top of the root ball. And we'll just pour that all in. And I imagine most of you guys are thinking, I know where that's going to go. It's going to go right down to the substrate. And I'll show you in just a second.
Percolator.
It is. It's percolating down. So this is going to go right down to the bottom. It might take a moment or two, but even as I lift it up, I suspect that Mr. Mandefield can see that the water is down below here. Is it making its way?
It is.
And again, it passed through the activated carbon, which means that it's getting a little bit of a scrub down. It's getting cleaned and purified. So this guy is ready to go. the last step, of course, is we got to seal this baby up. So, this is kind of tricky, or it can be. You want to make sure, of course, that you get all of the plant inside of here. This one's grown a bit since we started this one. But anyway, you get the whole thing in here, like so. And then what you want to do is you want to line it up. Remember when you put your hole there at the beginning?
Ooh, that helps you reline it up.
Yeah, it helps you line it up so you know that it's completely in place. Good. And then this is really one of the most important parts. This is going to be a closed ecosystem, meaning no new air or moisture will be able to get in or be able to escape. So we want to make sure we seal this baby up tight.
So a little bit thicker tape if possible.
Yeah, and
You see how he...
And by the way, when we do this, you guys, we want to make sure that we don't skimp on tape. Mr. Manifeld's right. We could have thicker tape, but since most kids have usually Scotch tape around the house, or what I call Scotch tape, just regular tape you might use to wrap packages or what have you, this is a good enough material. Just make sure, though, that you go around it maybe a couple of times to make sure you have a really good seal.
To keep it closed.
Yeah, it has to be closed.
Not just the top on closed, but closed as in you don't want air, not air, but liquid to get out of it.
Absolutely, because if the moisture escapes, what do you think's going to happen to your plant?
It's going to die from
Yeah,
that.
because this is a closed ecosystem, just like planet Earth is. There's no water being added to the Earth or our atmosphere. It's just cycling through. So we want to make sure we got a really good seal on this thing.
That's one of the coolest things about this, Mr. Gilroy, that I really was fascinated with, is that you don't need to water it. It's like it takes care of itself because it's a closed ecosystem.
Exactly. Like these guys are all just flourishing just fine.
You can see, Mr. Gilroy has not added any water.
No.
It's just evaporating up. It's stopping at the top and condensing, condensing. And then once it gets heavy enough, it falls back in as precipitation.
Precipitation.
Hey, that's PTPA.
Yeah, PTPA. Speaking of, so the most important step is about to occur, and I kind of pre-did this card. I kind of cheated Mr. Manifield just so we could make it a little bit easier. So now we're all set. We got our rainforest biome, but science is all about observation, research, hypothesis. Well, we have to keep, in observation, we have to keep two types of data, qualitative and quantitative data. So we have to know, we can obviously do our qualitative observations, notice changes in color or textures or what have you, but the quantitative part, the measuring of the plant, the measuring of the ingredients, the measuring of different layers, etc., is also one of the big things that you need to do is remember when you started your experiment. So you want to make sure
So you're labeling it
that
now.
you label it. And what I would say, and I'm not going to do this one for you this time because we did a lot of research in class, is I'm labeling this experiment as my biome. And if I were doing this myself, I would identify the biome. I'd say this is my rainforest biome. But more importantly, I would want to do some research on PTPA. In other words, rainforest biome. What's the level of precipitation in a rainforest? What's the average temperature?
You just find that right on the internet,
you can
right?
find that on the internet. I have one over here, and I think another one where I've actually done that research for you, but I want you guys to look it up. What's the level of precipitation in the Amazon rainforest, for example? What's the average temperature? What sort of plants are there? And without giving away too much, the rainforest is the most biodiverse biome on planet Earth. So there are more species, I think up to 30 million species in the tropical rainforest that are found nowhere else on Earth.
That's why it's so important to protect it.
Exactly.
You get a lot of medicine and stuff.
Exactly. So plants and animals, that's where you might say it's home to these species of animals, or talk about biodiversity.
What's this last thing you have on
This last thing, thank you, Mr. Manifield, is probably the most important aspect of labeling. You want to put the date that you began your experiment. Today is 9/11, so we've got that all labeled. It's ready to go. And now, using the scientific method, you can begin your observations starting today, as soon as you build this thing, and then start adding your research. Maybe come up with a hypothesis. What's going to happen to the water? Where's it going to go? How big is the plant going to get? Is it going to need anything else? Maybe do a little bit more research on the plants and animals of tropical rainforests, etc.
Let's kind of look at these biomes.
Yeah.
So
There you go.
there's some biomes. These are already done. Okay, there's the desert one, of course the rainforest one, another desert one. This is the one where it had the ants in it and they're already digging burrows. Look at it. It's literally bringing it down in the hole right now as we speak.
Oh, is it? Oh,
Yeah.
look at that.
Cool.
Yeah, and they kind of volunteered. They hitched a ride with them.
And I kind of am getting busted, Mr. Gilroy. Look at mine. It looks so beautiful, but what's missing? There's definitely something missing on mine.
Oh, yes.
I never what?
So he never labeled it. He
I
never
still need to
showed-
label mine.
He never showed his start date.
But
And what I
do
do like about Mr. Mandelfield's is he's got both biotic factors. Of course, he's got the plants and the fish, but then he's got an abiotic factor.
Yeah,
this
that's
pink
plastic.
thing. Yes.
But it's cool.
But it's cool. And the fish are actually loving
Wait,
it.
it's okay to have fun in science?
Absolutely. I've had kids put Legos in their biomes. It's, science can be a lot of fun. So now you know how to build a biome. And I hope you enjoyed it, and I hope you build one and show it to us. Happy science.